So today we're going to talk about parabolas. And so first we're going to define a parabola. A parabola is a set of all points in a plane that are the same distance from a given point called the focus and a given line called the directrix. And so I have a diagram down there of what a parabola looks like. Now a parabola can open 4 different ways. Okay, this is just one of the 4. It can open either up, down, left, or right. This one in this case opens up. And so real quick, if you look at it, you notice that the parabola has a vertex. That vertex is located, okay, at either the highest point or lowest point. In this case, it's at the lowest point because this graph opens up. Okay, the distance from the vertex to the focus, we call this distance P. It is the same as this distance here to the directrix. So those two are the exact same. Okay. The directrix is always perpendicular to that axis of symmetry. Notice I have that axis of symmetry in blue. What would be a way you could describe the axis of symmetry? Or what does the axis of symmetry do? It's a vertical line that intersects the vertex. What else does it do? Cuts it into half. Okay, it's like that mirror image. And so that's how you can think about the axis of symmetry. It's just a line, it goes through the vertex. Okay, cuts the parabola in half. Another thing about the focus is always on the interior of the parabola. Meaning, if I were to shade and color in this parabola, the focus is located in there. Okay, directrix is always located outside. So that's kind of one of those things to keep in mind. So let's go ahead and look. Here are examples of parabolic shapes. The Superdome in New Orleans. Granted, this is a 3-dimensional parabola, but it's still parabolic in shape. Okay, that dome is. Headlights and flashlights. If you ever take a cross section of a headlight or a flashlight and cut that, it's going to be parabolic in shape. Okay, the trajectory of a baseball. So that means if you throw a baseball or hit a baseball, generally it's going to be parabolic in the way that it travels. Same with a football. When they punt a football, it's parabolic in shape. Okay, trajectory of a rocket. Back in the early war days, they used to actually map out trajectories, and they used to do like the calculations by hand because they didn't have computers. So they had to have their math down pretty well. And then suspension bridges. This is an example of a suspension bridge. You're going to notice I drew a red line in there. That's actually a parabolic shape as well. Okay. So there's a lot of places where parabolas are and where they're used. Now, if you want to go ahead and write this down, okay, we're going to go ahead and talk about each of these individually in a little bit now. Oh, there we go. Okay, so now some of you have already written down the different shapes. What we need to do here is, if you notice, this graph opens up or it opens down. So let's look at the equation and see a little bit about the equation. First of all, with this equation, it has an x squared, okay, equals 4p times y minus k. Remember what we learned about, there is a vertex here, which is the high point or the low point. So I've got a vertex here. That vertex is always located at the point h, comma, k. Now you're probably like, well, how would you remember that? H always goes with the x. So it's whatever number goes with the x, and you're going to take the opposite of that number. You'll always take the opposite. Whatever number goes with the y, you'll take the opposite again, and that's where the vertex is. And if this isn't making sense, that's okay, because when we look at an example, hopefully it will. Now we know that the distance from the vertex to the focus is p. We learned that on that diagram, right? Well, here's where the p comes into play. Okay, it's always the number in front of the term that isn't squared. And once again, when we look at that example, I think it'll be a little bit easier for you to understand. Let's look at the next one here. This graph either opens to the right or to the left? So let's look at the equation. Notice what is squared this time. The y is what is squared, so basically we flip-flopped. Vertex again is going to either be the furthest to the right or the furthest to the left, and it's going to be located once again at HK. So we're going to jump right in with an example right now, and we're going to look at that, and we're going to see kind of how some of this works. So it says for y plus 5 squared equals negative 12 times x minus 2. Identify the vertex, focus, axis of symmetry, and directrix, then graph the parabola. Alrighty, so very first thing what I'm going to do is I'm going to find the vertex. So I know the vertex, and I'm going to symbolize the vertex with the capital V. If you want to write the word vertex out, that's fine, but I always use a capital V. I'm going to look at the x's and the y's. Here's my x. It says x minus 2. So my x coordinate of my vertex is going to be positive 2. Remember, it's always the opposite. Now I'm going to look at my y coordinate now. What's my y coordinate going to be? Negative 5. So now what I'm going to do is I'm going to go put a dot at 2, negative 5. Okay? So we're actually going to graph as we go through and solve. I think that will help you visually see how things are going to be. And I need to now determine, does the graph open up, down, or left, right? So let's look. We always look for the squared. The squared is with y. So is this going to open left, right? Or up, down?
Left, right.
Left, right. Now I got to figure out, does it open left or does it open right? So let's see. In order to figure out if it opens left or right, I'm going to look at this sign right here. This sign is negative. So do you think negative is going to be indicated by left or negative indicated by right? Left. And you're right. The reason why is because if you think about on the coordinate plane, your negative is always on the left side, right? Your positive is always on the right. So I'm just going to go ahead and draw in a parabola. There you go. So we found the vertex. We know which direction it opens. Now I need to find the focus. So to find the focus, I'm always going to focus on this number right here. And I know that 4p equals 12. Now for those of you saying, well, it's a negative 12, the negative tells us what direction it opens. From then on, don't use it. Okay, so kind of ignore that negative. So what does p equal? If I solve that equation, what does p equal? 3. So now let's talk about what that means. That means that from my vertex, I'm going to go 3 to the left, and I'm going to go 3 to the right. Now of those 2 points, the blue or the green, which one is the focus? Why the blue? Because it's inside, that's exactly right. So the focus, I need to come up with the coordinates of that. So just in looking at the graph, what would the coordinates of the focus be? Negative 1, negative 5. Very good. So far I don't have much left. I have like 2 things left. I got to come up with the directrix. And which one, what color symbolizes the directrix? The what?
Green.
The green. Okay, now the directrix, if you remember, did not touch the parabola. So I'm going to draw a vertical line in. Now if I would draw that horizontally, it would. So that's not going to work. So here's my directrix. So I need to remember, vertical line, does that go with X or Y?
Y. X.
X. Okay. So this is a vertical line, and I need to come up with an equation for that. So it will be X. And what's my X coordinate here going to be? 5. So my directrix will have the equation X equals 5.
Wait, how is 5 in there? It's
Because
5 over?
it's 5 over, yep. Final thing I got to figure out is my axis. Is my axis going to be, axis of symmetry going to be a horizontal or vertical line? Horizontal. And where does it go through? The vertex. So basically, here's going to be my axis. So if it's a horizontal line, it's going to have the opposite variable as this. So it would be y equals, and let's see where where did you say it was located at? -5. So see, it kind of helps to graph as you go through the problem, because that helps you visually see what the focus and like what the axis and directrix are. We're going to look at another one, and this one will go faster, trust me, because we've at least got a foundation. So if you want to just go ahead and write the equation down, you don't need to write, everything like find the, just write the equation. X minus 4 quantity squared equals 8 times y plus 3. And we're going to try to follow the same pattern that we did in the previous problem. So what should I start with? The vertex. And where will the vertex be? Close. 4, -3. Yep. Always got to go with the x first. So 4, -3. Okay. So 4, -3. Now I've got to figure out what direction is it going to open. So is it going to do the up, down, or the left, right?
Up, down.
Because
It's the x is first.
the x is squared. That's when we're looking at the up, down.
So when it's squared, it's up, down?
If the x is squared, it's up, down. So here we go. I have two choices. Up or down. Do we remember what number we look at now to determine which of the two?
Up.
The 8. Yep. And the 8 is positive. So of those two, which one indicates positive? Yep. So there we go. So we're just going to go ahead and draw in a parabola here that opens up. Okay. Next step, we've got to find what P is. So I know that 4P will equal what in this problem? 8. So P equals 2. So from the vertex, I'm going to go up 2, and then I'm going to go down 2. What does the blue one tell me? The focus. And what is the coordinates, or what are the coordinates of the focus? 4, -1. Very good. Okay. What does the green tell me? The directrix. Is it going to be a vertical or a horizontal line in this problem? What?
Horizontal.
Horizontal. Okay. So directrix will be y equals, yep, negative what?
5.
-5. Very good. And then last but not least, what do I have to find?
Axis.
Axis. And where will that be?
X equals
X equals what?
4.
4. There you go. So axis is going to be at x equals 4. Okay. So, questions? We're actually going to stop there today. And so if you want to get started on your homework, we will finish tomorrow. But if you want to get started, that's what your homework assignment for this section is. You obviously won't be able to do everything. Okay? But if you want to kind of get started, go ahead.